In this video, we're going to learn how to write equations of parallel and perpendicular lines. First, to start off by definition, parallel lines have equal slopes. They never intersect, so their slopes stay the same, so they never intersect. Meaning that, while m1 and m2 between these two equations will have equal slopes, most likely b1 and b2 will be different. If both of these were the same, then they would have been the same line, and not two parallel lines. Now, the slopes of perpendicular lines are negative reciprocals of each other. That's what creates the right angle between them. So, the way you define what a negative reciprocal is, if we multiply m1 and m2, those two slopes together, it should give me -1. Negative because they're opposite of each other, and 1 because they're reciprocals of each other. And then you can see down here, m1 is equal to -1 over m2, or m2 is equal to -1 over m1. The fact that you can swap them like that makes them reciprocals. So I'll start out with this first example. What is the equation of each line in slope-intercept form? So the line that is parallel to y equals 6x minus 2 through the point 1, -3. Now, if I were to plug 1 into this equation, I would get 6 times 1, which is 6, minus 2, which is 4, and 4 is much different than -3, which means that this line does not go through that point. We're just using this line as a reference for example, this red line, and we're looking for the green line. So first I need to identify what the slope of this parallel line is going to be, which if it's parallel, I see that this slope is 6, so if it's the same slope, m will just equal 6. So to move further onto the problem, I want to put in slope-intercept form, but in a previous lesson we learned about point-slope form, which is actually the easiest form to put one of these equations into. Because now I have a slope and I also have a point, which is 1, -3. So putting this in point-slope form, I'll have y minus y1, which is -3, is equal to 6 times x minus 1. Simplifying this equation, I get y plus 3 is equal to 6 times x minus 1. Now it's very easy to make that equation using point-slope form, but since I want it in slope-intercept form, I need to solve for y to put it into that form. So I'm going to start by distributing the 6, give me y plus 3 is equal to 6x minus 6, and then I'll subtract 3 from both sides, give me y is equal to 6x minus 9. And that will be my solution. You'll see here that they have the same slope and definitely two different y-intercepts, so they're going to be parallel. And just to check, if I plugged 1 into this equation, I would get 6 minus 9, which is -3. Therefore, I know for sure that this is the parallel line that goes through that point. Now, this next line we'll find is perpendicular to a given line. Y equals -4x plus 2/3 and goes through the point 8,5. Now, identifying this slope requires one more additional step of effort. Since there have to be negative reciprocals, I'll just put -1 over and plug in whatever the slope is of the line that we're referring to, which is -4. Now, negative of 1 over -4 is positive 1/4. And there we go. That is the slope of my perpendicular line, positive 1/4. So when I go to put this in slope-intercept form, I'll have y minus 5 is equal to positive 1/4 times x minus 8. That's in point slope form, but I do want to put this in slope intercept form to complete my problem. So I'm going to distribute the 1/4. Give me y minus 5 is equal to 1/4 x minus 2. And then I will add 5 to both sides of the equation. Give me y is equal to 1/4 x plus 3. And there is my perpendicular line. You'll notice here that they definitely have two different y-intercepts, but you'll notice their slopes are opposite reciprocals. And again, just like the previous example, if I want to make sure this is the correct answer, after identifying that they are negative reciprocals of each other, the slopes, I can plug in 8 for x and see that I get 5 for y, and that checks my answer for me. Now for the last example, I have a line that's perpendicular to y equals positive 2/3 x minus 1, and it goes through the point 0, 6. So identifying that slope, I will have m is equal to negative 1 over, in this case, 2/3. Now when you have a fraction in the denominator, when you're to find its reciprocal, it's just like flipping the fraction upside down. So our negative reciprocal slope would be negative 3/2. Kind of looks like the fraction just flipped. Now when I go to put this in my point slope form, I have y minus 6, this is my y1, is equal to negative 3/2 times x minus 0 in this case. So when I go to simplify, it's not so much that I have to distribute the negative 3/2, but rather just leave off the 0 and write this as y minus 6 is equal to negative 3/2 x. And then put it in slope-intercept form. I add 6 to both sides, give me y is equal to negative 3/2 x plus 6. Now one thing that's very interesting with this problem is it didn't tell you this explicitly, but this point right here of 0, 6 is a y-intercept. So I could have saved a lot of time just by recognizing that's the y-intercept, and I could have gone from finding the slope is negative 3/2 straight to the answer, because I know that plus 6 is the y-intercept.